This is Hallicrafters Rehab. I'm Albert. Welcome back. Today we're going to do the voltage checks on this thing live. Couple of things. I had a batch of bad fuses. Kept wondering what was going on, and something about the specs that I didn't understand or whatever, but I've got the right fuses in right now. So I'm at 50 volts AC, and it's developing 150 volts on the B+. My dad is doing fine. He's had just a little more strength this week when I was there. He was able to do all the walking he wanted to do. We're going to have a real good time checking the voltages, aren't we? Let's try this. Okay. And a couple things I had to do. My 9-pin extender doesn't work well, or something's not working well. So I'm pulling this 12AT7 out, and this 6C4, which is the 50 kilohertz notch filter box last IF amp. I've pulled the back off so I can check voltages on that tube, and hopefully I will be able to figure out at least some of the pins as they extend through the penetration here by color. They're color coded. Maybe we can find some substitutes for determining pin voltages on the 6AT7. We'll be looking for that. So I've got my sheet here, and we don't care about watts. 11 watts is like the most useless. 228 milliamps at 50 volts AC. And the first tube is a 6CB6 V1. 228. And we'll be looking at pin 1. This is going to be hard really for you to see. Okay, so I also I'll go over the 12AT7 in just a second, but I wanted to get this one too separately. This is the 6C4 in the 50 kilohertz notch filter box, and going through it and discovering that pin 5, which is right here, is not connected yet. The schematic says it is connected to the plate, and they both see the plate voltage. Well, there's really nothing on a 6C4 tube connected to pin 5, and so doesn't have a voltage, and there's no connection, and I verified it on the other one as well. So there's no wiring mistake. I was wondering, I'm not seeing plate voltage on pin 5, and then according to the schematic, and in fact there's not supposed to be. So I did get basically on the 6C4 a plate voltage reading for the pin 1, and the others were all 0. So I went through the 12AT7. I don't know if this is very readable where I've got the camera, but basically all there was for that at this level is the plate voltage of 148 to 150, and the filament is pin 9, 265. So that's where we are right now. I'm not going to do all these recordings at 50 volts on camera, but these were the hard ones. So I'll put all the tubes back in and finish up with this, and then we'll come back. Okay, here's another look, close up with the macro lens, such as it is, of the physical wiring redesign of the B+. So we have the filament leads coming here, and then it comes around. This would be, I think, I can't remember what they are, but I believe this is the right here. Let me get my camera. I'm trying to hold this steady and oh, okay. All right. Right there would be the half moon on a typical can capacitor. Then it goes through the choke from here to here, and then this is where most of the B+ comes from. And then there is a 10,000 ohm resistor down to here where the 6SC7 gets its B+. So these are, I switched back to these capacitors. These are 22s, and this is a 68, and they sort of fit nicely in here. So that's what it looks like up close. Just to verify, I don't have the macro lens on here, but the big gray matter in here is not brains, it's actually the plate. And there is a lead coming to pin 5 on this side and to pin 1 on this side. So yes, 1 and 5 are plate, but if you connect to 1, when it comes to DC voltage, you connect it to them all. So it is indeed connected in the tube, even if it's not. There's no purpose in connecting it in the tube socket. 6C4 tube, 6C4. Okay, so I did get through all the voltage measurements. They seemed consistent for such a low AC input to the radio. And there were 3, is it V4? Somewhere in there. Can't reach, right. There were 3 places I could not reach, even with these extenders, safely, because it's just not enough clearance. They really have it tightly designed. And even with this extender, you just can't get it. These probes are, you start taking these off and you're measuring, B+ voltages and coming across the side of the shield and that kind of stuff is not a good idea. However, I can infer the voltage because pin 1 is test point A on the schematic, and it was 0, and pin 5, which is the plate, is the blue lead coming out, and that was at what it should be, around 136 right now with such a low input voltage to the set. So all the tubes are in place, all the extenders are out for now, and I'm going to stop here. And the reason why I'm going to stop is because, well, I should test that other 5Y3 one more time, but I've got a rectifier tube on order, and I'm sure that will be the one I use, not the one that came out of the set, or my rather weak one here that I've been doing these first tests with. But I'm really happy with the results, and it's looking like it's going to work. Now it's time to focus on the metal case. Okay, so it matters about tubes. This is using the 5Y3 from the set that I pulled out, and I'm seeing voltage went up to 90, that's down to 60, and it was 150 or 140 in that range with the other 5Y3. This one is no good, and for the trash can. So I've got that tired one to work with until the other one arrives, but this one is a waste of time. We need to turn it off or something happens. Okay. So this one that came out of the set is bad. And that was throwing me for a loop, I think, early on. I was wondering if the thing worked. And the answer is not with that tube. Okay, here's another look, close up with the macro lens, such as it is, of the physical wiring redesign of the B+. So we have the filament leads coming here, and then it comes around. This would be, I think, I can't remember what they are, but I believe this is the right here. Let me get my camera. I'm trying to hold this steady and oh, okay. All right. Right there would be the half moon on a typical can capacitor. Then it goes through the choke from here to here, and then this is where most of the B+ comes from. And then there is a 10,000 ohm resistor down to here where the 6SC7 gets its B+. So these are, I switched back to these capacitors. These are 22s, and this is a 68, and they sort of fit nicely in here. So that's what it looks like up close. So the lid I've cleaned up with half a dozen different kinds of things. I tried mag wheel cut polish, I tried the turtle wax, I tried alcohol and mineral spirits and lacquer thinner, whatever. And you can see it got a little bit of its old luster, but it's painted on in the first place. It's a very brilliant aluminum metallic finish, but there's some chemicals that was spilled on it, and it was covered with, you know, same old cigarette smoke stuff. So we're gonna give it a shot. First on the underside with this Krylon brilliant aluminum and see what happens. When painting with that highly metallic brilliant aluminum, it's very difficult to do this without getting streaking. I think I've done a fairly good job, but it's not as good as if you've got a compressor and a professional spray paint system, which I don't have. Meanwhile, while that's drying, I have my work cut out for me on this case, which has got all kinds of issues I need to go around with sandpaper and really work on it and prep it up to paint. It's got rust spots. It's not too bad a shape, but all that has to be smoothed out, scoring places and things like that. So I have plenty to do while that's drying. So the painting is complete on the case, the outer case, the back and the bottom, and the lid. On the case, painting is my Achilles heel among 25 or 30 different Achilles heels. I don't know how many. I only have 2 legs, but I have a lot of Achilles heels. This time it was having this all nice and ready to go, and then the next thing that happens is I go eat lunch and I come back, and what do we have? splotches coming out of the spray can because I didn't realize it got too hot. But it's been cleaned up and it's fine now. That's just dust. I was just thinking, what have I done? Okay, I've buffed it off with Scotch-Brite a little bit, very lightly, very lightly. On the inside, I used a charcoal gray primer, and I believe it has real charcoal in it because it was coated in a layer of black dust, which I removed with Scotch-Brite and got over me and everything else. There was enough to make my own fireworks. Anyway, it's gone, and so this is ready to go. You didn't want that stuff inside the electronics, I'll tell you that. As far as the lid is concerned, that's probably going to be as good as I'm going to be able to do it, which is far better than the last one I did. And the problem is, if you look down, it looks fine. It's been buffed out with lightly with Scotch-Brite and then a paper towel, shop towel. But the patterns that you see come from looking at it at an angle, which tells us that the holes themselves have different spray patterns inside of them, which is like impossible to deal with. So short of buying an automobile paint shop, or I suppose I could remove all the paint and send it off to an astronomer's mirror electroplating service and make a mirror surface out of it. If anybody has any better ideas, I'd love to hear it, but this is probably about as good as it's going to get. This is like the fourth or fifth time. The fourth time, I took paper towel and paint thinner and just wiped it in streaks across the top and just removed layer after layer after layer and got it pretty close. And then the last coat was just a quick spray with the it's actually an automotive product for spray for chroming. It's like spray chrome. I'm sure it looks like this when you do it on a car. Maybe not, I don't know. But I suppose it's easier to buff out a car bumper than it is to all these thousands of holes in here. And it has a very professional spray nozzle on it that is designed for an even spray and all this kind of stuff. But those holes, just unless I'm a machine or a robot or something, you're not going to get rid of some sort of pattern when you spray it. If anybody has any better ideas, let me know. But that's about as good as I'm going to be able to get it. It does look good when it's only when you're kind of angling and light on it and all that kind of stuff that you see these patterns. So that's where I'm at. Supposed to get the 5Y3 tube this afternoon. We'll take a quick look at the difference between the two and call this video for the week. The new rectifier tube came in. It's branded J&J. It's a beast compared to the Sylvania, but tested about the same. Let's see how much voltage it will develop compared to the 150 with the Sylvania. Okay, we got it tied into the B+ right off the filament of the rectifier, and we'll start with isolation transformer. And this is on 0. Turn it on. The variac. You have a little bit of voltage here, and let's set it for 50 volts. It's 23. 160, 156, steadied off very fast. So another 2 or 3% from a reputable dealer, and stabilizing around 157. So that looks how that's going to be. I'll be using that one. So now I'm going to go through and do the 90 volt checks, and then we'll look over those before we proceed. Now it's steadying out at 150, so it's a good rectifier. So I've been, first thing I discovered is I had the standby receive switch on standby, and that changes all of the numbers, so I had to go back and redo the 50 volts, and everything comes out consistent with what it should be. So we are now ready to power it up to its rated value, and I'm actually going to do 118.3 because of the that's what it'll normally be operating at a nominal 120. With, of course, Duke Energy isn't always 120, but at any rate, we will. That's the nominal rating of the set. The inrush current limiter actually drops 1.7 volts off the line and preserves the tube. So we're at 90 volts right now, and we're going to bring it up to 118. That's 118.3. That's about where it'll be. Curious? Are we going to hear anything? Besides the beeping of the power going on. I have an antenna of sorts hooked up. Not much of one. Okay. I guess we can take this off. Oh, I'm hearing the station.
Only your word of mouth helps us reach new people. I also want you to know that our
Yes, indeed. I've got things backwards and upside down. I don't know what bands I'm on. That was only happening. That one's dead. That's interesting. That's the AM band. That'll be something to work on in the RF section. Completely dead on the AM band. That's interesting. We will take care of that, don't worry. Main 2. See, there's some rubbing in the antenna compensator. No problem, I'll get that ironed out. I've dropped a receiver on an antenna compensator before. Got it nicely mashed, but I unmashed it.
In the spirit of God around the world.
Yeah, shortwave's coming in good.
And we hope have a team in the spirit.
There's an issue with my...
Call me now.
That's an issue with the bandwidth. It's not operating properly, so we'll have to work on that.
/channel-finder. Full channel listing. In Chile, in Puente Alto, Santiago, channels.
It's Cuba. I'm not even looking at the dial. I'm just curious about band 1. Could be a switch issue. That's usually what it is. Alright, we're wasting time. Okay, we got to finish these voltages, and we're going to cut the ribbon on the V+. So I'll be back. Okay, so everything checked out as far as the V+ all the way through. A little bit of minor anomalies here and there, but I think when we start to admit signal through, and there is an issue with band 1, I'm thinking with the antenna coil itself on band 1. We'll see. It'll be pretty easy to find out. And so it's almost ready for, well, we'll have to find that problem. I've rebuilt fixed coils before in the past. I hope I don't have to do that. It may be a simple problem. But we'll be doing a little bit of debugging on that, and then it's ready to align. And the interesting thing is, I'll put this up here. The wax, you may not be able to see it, is still in the coil from the factory on everything but the oscillators. There it is. Now it looks like somebody's done a screwdriver right there, but not there. Clean as a whistle, not on the RF there, but on the high end. Here in the oscillator on the low band, never touched. Maybe he wasn't interested in that part of the radio, who knows. So that will be fun, taking that out and then finding out where that is after 70 years. So the big moment for the power supply is it's now operational, and it's time to cut the ribbon. I install a jumper around the, I don't know if you can see that very well or not. The jumper is around this inrush current limiter. And so what we're going to do is we're going to cut it and force the current through the inrush current limiter. Here we go. Someone play the band, roll the drum. We need speeches. All right. So now it'll operate normally when I turn it on. No more variac needed. And fully proven from a B+ and screen voltage point of view. Still a lot of issues to figure out, but that's okay. We're making progress. This is Hallicrafters Rehabs. Thanks for watching.